Hey everyone, I'm very happy to be here. And today we're going to talk about building let's say a custom GPT that can answer your questions. So I will present myself. My name is Tamar. I work with Node for I think 8 years. Actually my interest in Node started when I founded a startup of my own. And I wrote the entire backend in Node, and from there I wrote several backends in Node, including the backend for XM Cyber, which was sold in around $700 million in 2021. I still work there. This is my Twitter, this is my LinkedIn, this is my Gmail. You can contact me there. And today we're going to talk about writing a bot that can answer your questions on custom data on style of ChatGPT. And in order to do that, we have to understand, let's say, a lot of theory or a lot of, let's say, knowledge in the AI domain. So we're going to talk about a little bit about LLMs and how they work, their building blocks, and then we're going to get to the preferred architecture. To do that, we'll show the code demo, and then we'll talk a little bit about how to take it up to scale. All right, so let's start with what are LLMs. So I guess you know like the definitions of what are LLMs. So those are machine learning models that can generate text and comprehend text, and they're trained on massive sets of data. Well, but to understand how they work, we need to understand a little bit about, let's say, the levels. So we need to understand a little bit about machine learning, and then it's wrapped up with deep learning, and then we can start talking about LLMs. So layer one, what is machine learning? So machine learning is a mathematical algorithm that, according to parameters, can classify a problem. Here is a problem, for example, what is the price of an apartment in London? Or is it above or below $100,000? So I took here two parameters, distance to the city center and number of rooms, and the model is trained on a data set, classifies it, builds a graph, and then a new sample gets a label according to its place on the graph, whether it's above the line or below the line. But in reality, things are much more complicated because we have models with thousands of parameters and very complicated relations. So in that point, we're starting to use neural networks, deep learning. So neural networks are models that mimic how the brain works. Actually, it's like a graph, edges, and node, and each node is an artificial neuron, and they send input between them to get a result. Here's like a sample of a neural network that gets an image and classifies it as an image of a dog. Another thing, we're going to talk about text problem. Another thing which is important for text problems is we need to take text and actually transfer it to a numeric value. So that is done in a process called embedding. And in that process, you actually convert the text to vector. Actually, it's according to the context of the phrase, but you convert, let's say, a word or a phrase to a vector. And now we can talk about LLMs. So actually, the classification problem of an LLM is to predict the next word. They're trained on massive set of data and on different contexts, so they're able to generate a table on each point of the most predictable word by probability. All right, so when we have this ability, we're also able to generate text. I mean, let's look at this example. This is how LLM generating text and understanding text. I have step one, a trained language model can, and the next word with the highest probability is generate. And then in step two, we added generate, and then a trained language model can generate text. So that is really high level how they're working. Just a fun fact, well, the human brains, they work on a neural network, of course, and the human brain has 100 billion neurons, but ChatGPT has more. Just interesting to know. So several building blocks that you should know to write those applications. First of all, tokens. That's like the basic unit for an LLM. And a token can be one word or a phrase. And each question and answer is at the end composed by tokens. And then the temperature. So the LLMs usually select the word with the highest probability, but we can actually control that. There is a setting that allows us to tell the LLM, take words with smaller probability. Like here, the child likes to play with the zebra. But what will it give us? That is like a low temperature. I asked ChatGPT, what is Node.js? And he's telling me Node.js is an open source cross-platform JavaScript runtime environment that allows developers, blah, blah, blah. Good answer. And then I made the temperature very high, and I asked the same question, and that is the response that I got. You see, you don't understand anything, but sometimes it's good to control it to like get more creative responses. Another thing that you need to do to get to know is prompt. So when you're working with an LLM, you give it a set of instructions that it considers when generating the response. For example, here I gave it the instructions, you're a helpful assistant that helps developers to find bugs in their code. And, well, now I want to talk about hallucinations. So LLMs can generate a response which is grammatically correct, but the data is totally incorrect, meaning that they can lie with a style. I mean, they're really like, you're convinced that this is correct, but this is not. In order to avoid, well, one way to avoid this phenomena, it can be avoided by like more training, but this is not very reachable. I think that a good way to avoid this phenomena is by working with a prompt. And when you're saying to the LLM that if you don't know the answer, say you don't know, never make up, then I think that no hallucinations would happen, at least according to my experience. And the last thing we're going to talk about is the context window. So an LLM has the possibility to, if I'm asking a question, I can give data to the LLM that can be related to the question, and the LLM would consider that in the response. Okay, we've talked about a lot of theory, some kind of a crash course. So now let's talk about the architecture. So I would like to integrate my bot with data. How do I do that? So one way to do it is to do fine-tuning to my bot on data, but that is not a very good option. Why? Well, it's expensive, it's long, but a phenomena that can happen even to people which are trained in training model is that the model is forgetting its knowledge. So that is a path that I don't recommend to go in. But we've just talked about context window, right? We said that we can give the LLM data for every question. I mean, we can do that. There is a possibility to do that. So if I could give in the context window all the data, let's say that I have 0.5 tera of data, okay, and I'm asking a question, I would like to give all of that data to the context window. All right, so first of all, that's also not a way that you want to go through. Actually, like old versions of LLM had a context window which is limited and small, but newer has like huge context window, and then you say, yeah, I want to give everything to the LLM, 0.5 tera of data to the LLM. Yeah, I'm giving it. Okay, what is the problem with that? So LLM, behind the scene, is doing complicated computations. So if I'm giving it a lot of data in every question, so I ask a question, but not all the data and 0.5 tera that I give it is relevant for that question. And to do that, like, it's running really powerful actions, really powerful computations to find the relevant data. So you get to a situation that you are doing a really big effort to do a control F in a text document. So that is also not the path that you want to go to, but the path that you want to go to is to give the LLM the exact data which is relevant to the question. And now we're getting to talk about RAG architecture. And in that architecture, you can feed the context window with the accurate data that is relevant to each question. So RAG is actually combined of two steps. Step one, well, I need to ingest the data, okay? Probably I need to search it in a database on each question, so I need to have database. So I need to have an ingestion pipeline. So I have the data, let's say text. What I need to do is split it into chunks, load it, split it into chunks, and then do embedding. Remember embedding? We always have to do embedding when we're dealing with text problems and machine learning. So I need to embed the data, convert it into vectors, the chunk that I'm working on, and save it into a vector DB. And then step two is the architecture. After I have the database with the data which is embedded, so on every question I can retrieve the accurate data according to the index that I choose to get the most accurate data so the LLM can answer the question correctly. Okay, so to understand those things, you need to understand a lot of theory, but let's start to see some code. So LLM providers you can use, so I actually put here all the big companies, but there are a lot of providers that you can use. I specifically, for this demo, or also when I worked at it, worked with OpenAI, and I also worked with a library called LangChain, and it is wrapping the model, and it gives us the possibility that the APIs to work with it. All right, so initialing the OpenAI model, that is easy. We're importing for OpenAI, LangChain API, and I initialize it with GPT-4o. And now let's talk about the data ingestion pipeline. So we need to first load the data and split it into chunks. How this is done? Well, this is the loaders, for example, that LangChain is giving us. On a path, I'm loading, here you see PDF, text, and CSV. And then splitting the documents, again, there is a definition of chunk size. I need to determine the chunk size and also overlapping between chunks. That is a setting that you can play with. It can impact the answers. All right, so we're splitting the documents, and then for embedding them and saving them into the database. Okay, so regarding the database, I took Chroma. Chroma is a vector database which is popular on working with these kind of applications, and that's Docker Compose if you're interested. And this is saving the chunks into the Chroma DB. So here I did it with chunks, and each chunk that I get from the loader, I do embedding. I chose an embedded model from OpenAI, and I save it into the database. Now let's talk about the bot himself. So first of all, to retrieve the data. So we have a context retriever. You need to, of course, retrieve the data from the same collection. You've saved it, and you have to use the same algorithm that you use when ingesting the data. Here specifically, I took the algorithm of text embedding 3 small, and also I tell it to give me only the 6 documents which are most relevant here, and I chose search type, which is called similarity. And the prompt itself, as we said, this is another component that we've talked about. So that is the prompt. Again, we're using LangChain utilities. And we tell him not to make up answers. I wrapped everything with an Express server for this purpose of the demo. And the Express server is going to get a user question and answer it. So now let's go to the project itself. So I think I'm going to upload it to, whoa, that is small. Actually, everything is already up and running. And I think I will upload it to my Twitter. Let's start from the beginning, like the Docker is up, the server is up. This is the ingestion pipeline here. So actually, I hope it would make things a little funny, but I found several letters that Amazon CEO has sent to the shareholders, and I pushed them into my application, and we're going to ask a small question about them. So the letters are here. So running the ingestion pipeline, just that you can see the code, it starts in here. We're not going to run the ingestion pipeline right now. We're loading the documents, splitting them, storing them as vectors, and this is the server itself. We are getting a question, and the retriever is actually taking the documents from the database. We're putting those documents into the LLM. It is wrapped here in the RAG chain. It's another API that needs to be used, and it's gonna return a response. Great. So now we're gonna sacrifice something to the gods of demo. Just kidding. All right. So actually, I already started asking this bot some questions. So I asked him how Amazon overcome the fact that many physical stores were closed during the pandemic. I have a bug in the UI here. So it answered Amazon managed to the closure of many physical stores during the pandemic by significantly growing customer business, resulting in increasing annual revenue to blah, 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 whatever, whatever, whatever. I prepared several questions here in advance. Here is a question that sounds a little bit, maybe like marketing. It is how Amazon is going to be Earth's best employer and Earth's safest place to work in. All right, let's see what the Amazon CEO is saying. Oops, we are in the server. Yay, and we're going to wait a little bit to make it processing. Oh, yay, it answered. Amazon aims to be Earth's best employer and Earth's safest place to work through several initiatives. One, wages and benefit. They have increased their minimum starting wage to $15 per hour with a current average of, it's long, but you're welcome to read it. Let's ask another question, which is how Amazon would deal with the climate pledge. Let's see how Amazon is going to deal with that. I need to remove that breakpoint. Yeah. It takes time. Let's wait. Okay. Amazon plans to meet goals of the climate pledge by implementing several strategies. The company aims to achieve net zero carbon emissions by 2040, 10 years ahead of Paris Agreement targets. Key measure includes, anyways, they have a plan for that. Good. So this is about working. And now let's talk a little bit how to implement this architecture to support large scale. So first of all, the scale of the API layer is like, I think it's more trivial because we have a microservice and we can make several replicas of it, and we'll put a load balancer, nginx, whatever, and a question arrives to one of the replicas. It gets the answer from the vector DB, and we would have the LLM on each replica. But, if we have like a lot of data in the database, so this is the component that you need to play with, the context retriever. So you need, for example, I use search type similarity. There are other search types so that you can play with, but this is like the place where the indexing would need to be improved. This can be like a workshop of 3 hours, but that is like one point that you need to consider it, to be concentrate in. Now let's talk about the data ingestion pipeline. And from what we've seen, our problem is in all the data ingestion pipeline. I will soon show the code, and then I hope it would be clearer. But we're doing everything in memory, currently with the APIs that we have. Let's look at the APIs. So we're loading the documents, we're splitting the documents, and we're storing them as vectors. We don't have good way to serialize them or save whatever, the output between those phases. So if you have a lot of documents and you're loading them to a process, so that process can explode. So what you're doing in order to overcome that problem. All right, so just one suggestion is async iterators. So you have to do everything here, but this is just a code that goes over the file system, and we would probably have to do that like file by file. And you have to, like when a file arrives, you have to do like loading, splitting, and saving. You have to do everything all together, then you have to do it for each file. Also, worker threads are a possibility. Pay attention that what you transfer between threads has to be serializable, and here the output is not serializable. So again, you have to like transfer, let's say, the file name, and then each worker thread would do that process of loading and splitting and saving. And now this is like a suggested architecture for like even bigger scales. So let's say that I want to ingest my entire S3 bucket into a vector DB. So yeah, I would have to do it with probably object listing APIs of AWS SDK. And to list every file, again, we have to like transfer the files and the file names, sorry, not the file content. And each, let's say, consumer worker here would do the load, split, and embed to DB. And I am, I think, 2 minutes before time. So thank you very much, and I hope it was an interesting talk. I'm going to upload the code. The link to my GitHub, I'm going to upload it to Twitter and LinkedIn, I think. So it's going to be available there.
Thank you so much. Do we have any questions for Tamar? Okay. Okay. Thank you very much. That was really, really cool.